Hi everyone, before we get into the next probability lesson, I just want to go over some important info that some of you probably realized after doing your test. So there were quite a few of you that reported tech issues to me. Pictures won't download from my phone, I can't get it to work on D2L, my Wi-Fi is not very good. Pictures, file size is too large. Again, we tried to get all these kinks worked out before we started. That's why I sent out so many warnings. But it's okay. A lot of you still emailed me. That's good. Just try to get this figured out before the next test and assignment on Friday. So I've said it a few times, including at the beginning of the course when I had that D2L scavenger hunt for you guys. That was to kind of get you used to what you might have to do, and lo and behold, here we are. So some of you might be getting tired of hearing me say this, but download the app Genius Scan. It's free, it's super easy. Once you download it and open it, click on the picture icon, have all of your pages out in front of you, click on the camera icon, take a picture of each one of your pages, hit the check mark, and it has just saved all of your work as one PDF. The advantage to this is that a PDF file is much smaller than you guys taking HD pictures of your work and then trying to upload them. If you do this, you will not have any issues with saying like I don't have good enough Wi-Fi, the file size is too large. It's just saving it as a PDF, which is again much, much smaller. So try it. There's no deadline on how many submissions you could submit to your assignments, to your test locations. You can remove files, and you can keep uploading those things. So try it. Maybe try it right now, or try when this is done. Make sure you have things kind of figured out. Again, if you don't, I will accept pictures individually. It just makes it way harder for me, and you're probably not going to get good critical feedback on your test and assignment questions. Not only that, but with all the students and parents and people that like from the principals and the board office, all the emails I get, sometimes your things get buried and then I forget they're there or I happen to delete them by accident. Same thing if you send them to me in Asia. Sometimes they get buried in all the other messages that I get. So just a fair warning, if you can, hopefully after this test, you kind of worked out the kinks and you're ready to go for the next test. And again, if you still can't figure it out, I'll accept individual photos, of course, but if you can actually take some time today before your next test tomorrow to figure it out, again, take my advice, go on to Asia, which, by the way, if you don't have Asia downloaded, you should get it downloaded. It's just another easy way for you to attach things. And one more thing while we're on Genius Scan. Just so you know, because you are taking pictures and creating them, or creating a PDF with them, that PDF is not going to go to your photos. So when you're trying to upload, if for those of you that were, it's not going to go to your photos. It's going to go to your device files. So when you go to upload something to me or send it to me and you've actually used Genius Scan, make sure you're not trying to find them in your photos. You're going to have to go to your device files. And then from there, you should be able to figure it out. Just a little bit of advice to try to work out some of the many, many issues that some of you had. But that's great because you guys are proving to me that you're doing what you're supposed to be doing, and that you're asking lots of questions, which means that you care, which is all that I ask for. The last thing that I have here to talk about, some of you have done this, but there are Teams meetings daily. So you're watching these videos on YouTube, let's say, but I'm in Teams, so I've posted a link that I'm in there every day. And it's usually for like an hour or so before lunch, an hour or so after lunch. How do you get there? So I've just attached a screenshot from D2L or Brightspace, which, by the way, you can save yourself a lot of potential stress if you download Brightspace to your phone, especially if that's what you're using to take pictures of your work. But once you're in D2L or Brightspace, go to the activity feed. The first post that I have pinned there is math help, which has all the contact information, including the class code for Hasia. And then somewhere in the activity feed, there is a Teams meeting scheduled, and you just click on that. So as your first piece of homework, I would say after you've watched this lesson, try it. Go into the Teams meeting for January 7th. Granted that it's between 9:55 and 11:55 or whatever time I have there listed. Go through the motions and make sure you can get it to work. And if for some reason you can't get it to work or you can't get in, then let me know. Keep in mind too that there is a lobby you have to wait in. So when you're just waiting in the lobby, I'll get a notification that says so-and-so has been waiting for you or has joined the Teams meeting, and I have to admit you to the lobby. Now I'm sitting in front of my computer or in front of my phone, so more than likely, or more often than not, I'll be able to admit you almost immediately. However, if it's over lunchtime, I'm not going to be there. Or if it happens to be I've stepped away from my computer to go to the washroom or something, just be patient. So if you're there and you're waiting, and if you're waiting for like a long time and it's not over lunch, then probably something is wrong. You might want to fire me an email or maybe even fire me a message in Hasia and just be like, hey, I've been hanging out in the lobby and it's not lunch and I've been in there for like 20 minutes. And I'll get back to you and let you know, see if you can figure it out. Now, why might you want to do this, especially on a test day? You can get real-time questions answered by me. So instead of you sending me emails or even messages in Hasia, and I have to decipher kind of what you're trying to ask or what question you have been working on, you could have that open, be like, hey, Sulio, I'm stuck on question 8 or I'm stuck on question 4 of this assignment. And I can give you feedback in real time and try to help you. I can also share my screen with you. So if there's more difficult problems, I can share my screen with you. Even start a whiteboard where I can maybe do this, try to write some things out for you to help you out. So it's a very powerful tool. Again, maybe make a point of your first piece of homework is after this lesson, drop in. Make sure there's no tech issues on your end. And then make sure your camera's off, but your mic is on. And then once I meet to the lobby, maybe just like, hey, Sulio, just giving it a test, just saying hi. I might be like, hey, it's going good to hear. And then you can leave basically there's like a hang up feature. You can hang up. And there's no limit to how many times you can drop in. So you can open it, ask me a question, leave. Come back a half an hour later because you have another question, open it, ask me a question, then hang up. So I think that's it for some of the important information. There are a handful of you that did not do your test. And if that's you and you're watching this right now, remember a part of desynchronous learning is you're doing the tests when you're supposed to be doing them when they're scheduled. There's not one of you that actually emailed me or contacted me and asked for alternative deadline and with a reason, other than one person, but they've already done it. So to everyone else, you're going to have to get in touch with me and we're going to have to figure out an alternative assessment for you. I'll also be sending messages home, and if I don't get feedback from you or I don't hear back from you, it's going to be like skipping a test, right? This is the synchronous online learning. And if you skip a test, that's a 0, right? And when it comes to marks, just know I have so much going on for getting this virtual learning up and going, recording these videos. More than likely, I'm not going to get your assignments and tests marked until next week. So if you're wondering what your mark is, just hold off on asking me. I will post something in Hasia once I have things marked, and more than likely that's going to be towards the end of next week. Okay, so moving on to the actual math work. So yesterday we started probability, and we talked about experimental probability, and I gave you a very brief intro to some theoretical probability tools. So we're just going to continue from there, and we're going to do some examples. Just like for experimental probability, we have a formula for theoretical. So in the previous lesson, I showed you examples of theoretical probability tools. It's just another measure of the likelihood of an event, but it has nothing to do with actually conducting your own experiment. So remember yesterday for experimental, you conduct an experiment or you do something a certain number of trials, and then you count what you're looking for. Theoretical is literally just the theory, like what should you expect? What should happen? The formula is basically the same, or at least the same setup. So remember, for good communication, capital P, and then in brackets, so just to remind you, any question that asks you for probability, if you want to get good communication, you got to have that capital P. And then we'll say some event A equals outcome A divided by total possible outcomes. So we're going to do a bunch more examples, but a very quick example. If I ask you what's the theoretical probability of getting a head on a coin, a fair coin, how many heads are there on a coin? 1. How many possible outcomes are there? 2. 1 out of 2 chance, 50-50. So next couple of examples are going to go over some things that are really important that you're going to have to recreate. This is one of those things. So make sure you know how to make a tree diagram. And we're going to pretend like we are randomly making a sub from Subway, let's say. Doesn't matter where from, but we are going to make a tree diagram. You need to know how to make a tree diagram. Test, assignment, CCA. The first thing that you need to have are headings. So, headings. The second thing you need to have are what's called branches. And then your third thing you need are outcomes. So what's the result? So the first thing we're going to start off with headings. We're going to make this a simple tree, or a relatively simple tree diagram. So let's say you go to Subway. What's the first thing that you have to pick? Your bread. So there's one heading. Maybe after that, you want to pick the meat. Then after that, you want to pick, let's say, the cheese. And then your final heading is always outcomes. What was the results? So there's step number one. Make your headings. And again, it's not always going to be bread, meat, cheese outcomes. That's for this specific example on if you were to randomly make a sub. So let's say that, just to make it simple, we're not going to use all their breads. Let's say Italian and herb and cheese. So I'm going to write Italian underneath bread, and then I'm going to write herb and cheese. Now for meats, let's say you pick salami, turkey, and ham. You're going to have a branch coming off of each bread type. So we're going to start here, and I said salami, turkey, ham. And that's possibilities for Italian. If you randomly picked herb and cheese, you'd have the same options. So we're making our branches: salami, turkey, ham. Now for cheese, let's say you pick Swiss or cheddar. Again, we're not going to do all of the possibilities because our tree diagram would be huge. So then you're going to make and I'm just going to color code this, but you can make it all the same color. Then off each meat, you're going to have Swiss and cheddar. So branch, Swiss. I'm just going to write ched for cheddar. Swiss, cheddar, Swiss, cheddar, Swiss, cheddar, Swiss, cheddar, Swiss, cheddar. So there's our tree diagram done. In terms of our headings and our branches, the final thing is your outcomes. So I'm going to use the highlighter. So here's how you make your outcomes. You literally start at the beginning at the left and you just trace along each branch. So Italian, salami, Swiss. I'm going to use just the first letters for information. So Italian, salami, and we'll say SW stands for Swiss. And then, then you go to the next branch, which is still Italian, still salami, but now we have to take care of that branch. So Italian, Italian, salami, cheddar. Okay, now we go to the next one. Italian, and you don't have to use a highlighter, I'm just doing it so you can see where I'm getting these from. Italian, turkey, Swiss. Italian, turkey, Swiss. Italian, turkey, cheddar. I'll do it one more time. Italian, ham, Swiss. Italian, ham, cheddar. Hopefully you are understanding what I'm doing here, how I'm getting these. We're going to keep going. So the next one, herb. So we'll do herb and cheddar, salami, Swiss, herb and cheddar, salami, and cheddar, herb, turkey, Swiss, herb, turkey, cheddar, herb, ham, Swiss, herb, ham, cheddar. Now, how does that help us come up with probabilities? We've just listed all of the possible outcomes if you randomly picked your sub based off of these breads, meats, and cheeses. Count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what that means is all of our probabilities are going to be out of 12 because there's 12 possible outcomes. So I could ask a question like, let's just try this. What's the probability you randomly pick a sub that's Italian and salami? So I go and count up. So Italian with salami. And you kind of have to know what your letters stand for. So there's Italian and salami, and there's Italian salami. So that would be 2 out of 12. What if I said, what's the probability of picking a sub that has cheddar and turkey? So you go through your outcomes. There's a turkey and cheddar. There's a turkey and cheddar. That's 2 out of 12. I could say, what's the probability of having a sandwich with Swiss on it? There's Swiss. There's Swiss. That's 1, 2, 3, 4, 5, 6. 6 out of 12. So hopefully that makes sense. We're going to do a few more examples over the next couple of lessons with tree diagrams. Again, I can't stress this enough. Make sure that you know how to do this. Our next useful, helpful hint of what to make sure you know how to do is making a dice chart. So I'm going to start this. Make sure you know how to do this. So we're going to come up with the probability that you rolled doubles with a pair of dice. So what you do is you put all of the outcomes of the first dice across the top, which if we're talking about dice, the options are 1 to 6. And on the second die, what are your options? Same thing, 1 to 6. And I'm going to say sum is what we're going to use the most often. And sum means you add the dice. So in this first box right here, that's like rolling a 1 and a 1. What does that add up to? 2. The next one right beside it, a 1 and a 2, that adds to 3. And you just keep adding those numbers in the squares, right? So again, to get this one, I just add these 2. To get the next one, add the next 2. And then 2 plus 1 is 3, 2 plus 2 is 4. And you just keep going from there. And all I'm doing is just adding up the 2 dice numbers that lead to that box. Now, if we want to figure out how many possibilities there are if you roll 2 dice, count up all your squares. Not the outside ones, just the inside ones. So 1, 2, 3, 4, 5, 6. And that's 6 by 6. So all the probabilities for this are out of 36. So if you roll a pair of dice, there are 36 different possibilities. And remember, this is die number 1, and this would be die number 2. So let's do some practice questions out loud. I said, what's the probability you roll doubles? 1 and 1, there's a double. 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6, be 6 out of 36. I could say, what's the probability you roll a sum of 7? Take a look at your chart. 1, 2, 3, 4, 5, 6. There's 6, 7, 6 out of 36. I could say, what's the probability you roll a sum of 10? 1, 2, 3, 3 tens, 3 out of 36. I could say, what's the probability you roll a sum of 13? Look at our chart. I don't see any 13s. That means it's impossible. 0 out of 36. Just like our tree diagram, this is something you're going to see pop up over and over again in important places. Make sure you know how to recreate it. Make sure you know how to use it. It's not that bad, hopefully. So now to some other examples. And just so you know, this lesson's probably one of the longest ones of the entire virtual learning. So if one card is drawn, what's the probability of each event? So we're drawing from a standard deck of cards. So what's the probability of a heart? Now remember, for good communication, we need a capital P. You can kind of cheat a little bit so I'll show you how. Save yourself some writing. We'll put that in brackets like that. So the probability of a heart. How many hearts are there in a deck? Remember from the first lesson, you have to know decks of cards. We went over the information. You have to know it. 13 out of 52. How to convert that to a percent? Divide, multiply by 100. That's 25%. Next one, probability of an ace. How many aces are there? 4. Out of how many cards? 52. As a percent, using our calculator, 4 divided by 52 times 100. We'll go to one decimal place, 7.7%. Next one, probability. So we're getting a little bit harder. Probability of a heart, a club, or a jack. So we're going to think about this a little bit. How many hearts are there? 13. How many clubs are there? 13. How many jacks are there? 4. So far, so good, if that's what you were thinking. However, we're going to have to adjust that a little bit. We can't just add those up. So we know it's going to be out of 52 because there's 52 cards in a deck. However, is there a jack of hearts? Yes. Is there a jack of clubs? Yes. So by me writing 13 hearts, 13 clubs, 4 jacks, I've actually double counted 2 of the jacks. I've double counted the jack of hearts and I've double counted the jack of clubs because they're already included in my 13 hearts and my 13 clubs. So really, what's left over is not 4 jacks, just 2. Now we can add those up. 28 out of 52, which as a percent, 53.8%. Next one, probability of a black diamond. Out of 52. How many black diamonds are there? Hopefully you're going to say 0 because diamonds are red. That's not possible. 0%. A heart, a club, a spade, or a diamond. So probability of all those. Again, there's 52 cards. How many are hearts? 13. How many clubs? 13. How many spades? 13. Diamonds? 13. Those all add up to 52, which equals 100%. And that makes sense because those are the only 4 decks, or only four types of suits in a deck of cards. So getting any of those, you're guaranteed. There's only 4 of them. So here we are at another tree diagram. When flipping 2 coins, what's the probability you'll get each of these things? So you want to use a tree diagram whenever you have multiple events happening or multiple things you're using. So in our sub example, there was multiple ingredients: bread, meat, cheese. And here we have multiple things happening where we're using multiple things. We got 2 coins, so it's not just 1 coin. So we're going to start with our headings. Remember, we're making a tree diagram. So we'll say first coin, second coin, and you always need outcomes. What are the possibilities on coin number 1? Well, heads or tails. What's the probability for coin number 2? Heads or tails, but don't forget your branches. So off of this, heads or tails, off of this, heads or tails. My outcomes, start at the beginning, H and H, HT, TH, and TT. So all of my probabilities are out of 4 because there's 4 outcomes. So we'll cheat a bit here. Probability of only 1 head. We know it's out of 4. As I mentioned yesterday, if I don't tell you to do a percent or a decimal or a fraction, you can do it however you want. If you do it as a percent or decimal, round to 2 decimal places. If you do it as a fraction, then make sure your fraction is as reduced as possible. So only 1 head. How many of them only have 1 H in them? So there's 1 H, there's 1 H, that's 2 out of 4, which is 1/2. Probability of only 1 tail. How many of them only have 1 T in them? Only 1 T, only 1 T, that's 2 out of 4. What's the probability of getting 2 heads? How many have 2 H's? There's 2 H's. I don't see any other ones. 1 out of 4. Probability of at least 1 tail. So that means 1 or more tails. So this has 1 T, this has 1 T, and this has 2, which that fits in our definition of at least. So there are 3 out of 4. And just so you know, these are the types of questions you're going to keep seeing over and over again. So in summary, let's kind of taking a bit of a mid-lesson break here. Experimental probability. You observe and count outcomes or events, the events you're looking for. Theoretical is solely based off of what you should get. Has nothing to do with you observing anything, has nothing to do with you actually rolling a pair of dice, spinning a spinner, drawing a card out of a deck of cards. So theoretical probability is based off of theory. This is the what should happen. And remember, they may not always be equal. Nothing in life is guaranteed. So if you flipped a coin once, let's say twice, let's say 4 times, it's definitely possible that you got heads all 4 times. Does that mean that tails is not possible? No, of course not. What would you expect? Well, you flip 4 times and it's a 50-50 shot, so I would expect 2 out of 4 to be heads or 2 out of 4 to be tails. If you flipped a coin 1,000,000 times, you would expect a 50-50 split. If you actually did do that though, more than likely, because again, it's all based off of luck, it probably wouldn't work out to be an even, like dead on 500,000, 500,000 of each. One thing to note though, the larger your sample size, meaning the more times you conduct the experiment, the closer it should get to theoretical. This is why, for instance, say for sports, why they do best of sevens, or at least in the playoffs, because any team can win any game on any given night. But if you play the teams together 7 times, more often than not, the better team will probably win 4 games out of 7. If you did a 9-game series or an 11-game series or a 13-game series, you probably wouldn't see as many upsets, because the larger the sample size, the more likely that what should happen, which in sports, the higher seed should win. So, before moving on to the second half, you might want to take a little bit of a mid-unit break here. You're more than welcome to. Pause it, kind of wrap your head around stuff, maybe try some questions out of the workbook, and then come back. If you don't want to, then you can just keep going right from here. So this is part 2 of our theoretical probability, and we're just going to work through some more examples. So our learning goal is going to continue, again, like I said, to go through theoretical, not conducting our own experiments. So we're getting right back to decks of cards. What's the probability of drawing the Queen of Hearts as a fraction? So probability, Queen of Hearts. How many cards are there? 52. How many of them are the Queen of Hearts? Just one, only one Queen of Hearts. And we want that as a fraction. Perfect. 1 over 52. If I don't draw it the first time, and I don't replace it, now what's the probability? Okay. So this has one added step. So I drew a card. I didn't get it, but I don't put the card back in. How many cards are left? Well, we started with 52. I drew 1. I didn't put it back in. That means there's 51 cards. If I didn't draw, right, it says I don't draw it. If I didn't draw it the first time, there's still only one Queen of Hearts in there, so 1 out of 51. Which odds are better? Hopefully you're thinking the second part B, that's better odds. Example number 2. During the month of April 2019, at least some precipitation was recorded on 17 different days in Simcoe. What is the probability of choosing a day on which it rained? So don't forget all these P's we're doing. Capital P for probability. Don't forget, it's wasted marks given away on your assignment and test. Probability of rain. Okay, so what should this be out of? Well, you need to know how many days are there in April. Look at a calendar, look at your phone. 31 days. And we said that there's not 31 days in April, there's 30 days in April. So we're going to change that. 30 days in April. And we want days that it rained. And it tells you in the question that some precipitation was recorded on 17 days. So 17 out of 30. And we want that as a percent. So divide, multiply by 100, 56.7%. What's the probability of choosing a day on which no precipitation occurred? So probability of no rain. Well, if it rained on 17 days out of 30, that means it didn't rain. What's left over, which doing some quick math, is 13. Percent, 13 divided by 30 times 100, 43.3. And that makes sense. There's only two different possibilities, rain or no rain. These two things added up equal 100%. Hopefully that makes sense. And hopefully we got our days right in April. All right, back to our tree diagram. Now, I didn't say that you had to use a tree diagram in this example, but you should be thinking, I need to use a tree diagram because there's multiple things happening. 3 children are being born. So we are going to use a tree diagram. First thing, headings. So we'll say, let's write number 1, number 2, number 3, and then outcomes. I use 3 because child 1, child 2, child 3. Just to keep it simple, what are your options for having a child? Boy, girl. And that's going to be the same for number 2 and number 3. But don't forget your branches. So boy, girl, and then same thing for child number 3. Boy, girl, all the way down. And then your outcomes, start at the left, at the top, trace through all your branches, work your way down. Boy, 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 girl, boy, girl, boy, boy, girl, 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 boy, boy, girl, boy, girl, 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 boy, and 3 G's. That means there are 1, 2, 3, 4, 5, 6, 7. There's 8 different ways you could have 3 children. So all of our probabilities are going to be out of 8. Now I'm going to go to the next slide. You guys will be able to refer back to this tree diagram in your own notes. So we're going to use that tree diagram to determine each probability. So probability of 2 girls and 1 boy. Probability of 2 girls, and we'll say 1 boy. We know it's out of 8. Go through your tree diagram. Count how many of the possibilities have 2 girls and 1 boy. In any order, just has to have 2 G's and 1 B. There are 3. And I didn't tell you fraction, decimal, or percent, so I'm going to leave it as a fraction. Reduced as much, which that's as low as it gets. If you like percentages or decimals, go to 2 decimal places. Part B. What's the probability of 2 boys and 1 girl? We know it's out of 8. How many of those outcomes have 2 B's and 1 G? 3. So 3 out of 8 chance. Determine the theoretical probability of having at least one girl. So probability of at least just means one or more. So I'm going to write 1 plus girl. I know it's out of 8. How many of those outcomes in our tree diagram have at least one G? So go through, count them. I mean, they all do except for the scenario that has 3 boys. So there is a 7 out of 8 chance of having at least one girl. Hopefully we're okay with that. Hopefully we're getting better, more comfortable with tree diagrams. Now our last example. It's a bit of it's got a lot of work. It's not hard though. So if you've ever watched the show Price is Right, and there's a game on there called PLINKO. Now, I've given you kind of what the PLINKO board looks like. And how the game works on the Price is Right is you get chips. They walk up this big ladder to the top. They drop the chip down the PLINKO board. Whatever it lands is what they win. Now we're going to pretend that the contestant only has 2 PLINKO chips. Just to make it a bit easier, we want to come up with the following probabilities. So the probability you win 20,000, the probability at least 10,000, winning 1,000 or less, or winning nothing. So probability, probability, probability. So I'm going to show you how to get the answers, but I want you to come up with the answer, these final answers on your own. So this is going to be your first homework question. Now, if you're thinking to yourself, do I have to make a tree diagram? You could. It's going to be huge though. So sometimes what you could do is you can make a chart. So when we use 2 dice, we make a chart. We have 2 PLINKO chips, we're going to make a chart. So we're going to go through the work together on how to get these answers. And then on your own, I want you to take a look at the chart we make and come up with these 4 answers. And then if you have any questions, if you want to know you're right or not, then by all means, make sure you contact me. So here is our PLINKO chip 1 and PLINKO chip 2. It's a big chart, but it's just adding numbers together. So if you land this first square, that means that you landed in the 100 spot with both your chips. 100 plus 100, 200 bucks. 500 plus 100, 600. 100 plus 1,000, 1,100. 100 plus 0, 100. 10,000. Hopefully you're getting it by now. 10,100. 100. 1,100. 600. And 200. So I'm sure you could figure out the rest of those, but we'll still do it together. And then you'll take this chart and you'll come up with our probability answers from the previous slide. So I'm just going to fill it in without really saying too much. If you want to pause it, do it yourself. Definitely do that and come back. Again, all I'm doing is just adding all the chips up together. Okay, deep breath. Sorry about the silence. I know it doesn't make for a riveting video. So there's our chart. Hopefully I filled it in correctly. If anybody noticed any errors, definitely let me know. So to be able to answer our questions, which are going to be your first homework questions, I'm just getting you basically almost all the way there. You got to count up how many possibilities there are. So you don't count your chips. So we don't count these, and we don't count these, just what we filled in. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 by 9, 81. So there are 81 possibilities. So when you're doing your first homework question, answering those probabilities from the last slide, all your probabilities should be out of 81. Okay, good luck. Again, this was a longer double lesson, so thanks for staying tuned in. Just to recap from the beginning, try to get all the technical difficulties ironed out. Re-upload your assignment. Re-upload your test solutions. Make sure that you know how to do it. So that way when it comes to the next test on Friday, it's pretty seamless, you know what you're doing, and again, you're making life a little bit easier on me. The more of you that just do your pictures, which is perfectly fine, like I'll still mark them, the longer it's going to take me to get all of your marks back to you, and the less critical feedback I can give you. So again, good work so far, everyone. Almost through a full week. Please also note that there's a probability assignment for this unit. It's already uploaded. As promised, it's not just straight math. I tried to make it a little bit more fun, or at least a little bit different than just questions. So it does require some work. It does require some creativity. It does require some color. And no two assignments, this is the way it is, no two assignments should be even remotely close to identical. Everyone's making their own amusement park, which, spoiler alert, if you haven't opened it, there it is. So nobody's solutions, nobody's amusement park should be even remotely close. You are doing your own creative work. And that's due on Friday at 3 o'clock. So there's one more lesson after this, and then that's it for content for probability. As I mentioned to you guys before Christmas break, before I had to go into isolation, quadratics is long, trig is kind of Not that long, but a little bit longer than some of these other units. And now we're just going to kind of go like bang, bang, bang right through all our units, basically knock them off in like 2.5 days. So after this week, we'll have finished 2 units, and then you'll only have 2 more left. But we'll talk later for your last lesson.